Guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the coefficient of variation, and this is going to form a part of the types of different measures of dispersion which I've looked at in some of our videos. Now in this case, we are going to look at a specific ratio which is going to be given in terms of the standard deviation and specific mean. Now therefore, for us to understand the coefficient of variation, we're going to have it perhaps for the sake of space initialized as the coefficient of variation in our discussion, and therefore we can define this specific aspect of the coefficient of variation as a ratio between the standard deviation all over the specific average which we have given in terms of this specific representation, and of course which is going to be of course referred to as the mean expressed as a percentage. So I've translated this statement form basically in terms of this specific representation, and therefore we're going to find the coefficient of variations from a specific set of data using this specific formula. So in this case, I've said that this is going to be the standard deviation, and therefore we're going to have this second aspect of this particular average being our mean. So the ratio between the standard deviation and the mean expressed as a percentage is going to represent our coefficient of variation given as such. So we're going to consider this particular monthly wages for specific workers in two different industries, whereby I've given this specific value for the mean wage and the variance of the industry A and industry B. So for industry A, the mean wage for this specific workers is 52.5, and the variance is 100. For industry B, that's going to be 47.5, and the variance is going to be 121 in that particular order. So from our previous definition, we had basically said that we can obtain the standard deviation of a specific set of raw data using this summation of values from 1 to n over the particular variances given in terms of the square of these particular values divided by n minus 1 given as such. So this is going to be the root of all these specific values. So in this case, I said that this basically is going to give us what we refer to as the sample standard deviation, and this one basically is a derivation from the sample variance which we are given. So in this case, given the variance for the respective industry for A and B, and therefore we can compute this standard deviation using this specific formula. Now in our case, since we have been given these particular values for the first case for the variance of industry A, we're going to obtain this standard deviation given as 10 given as such. And for the second case, of course, we are going to obtain this standard deviation given a variance of 121, and therefore for the firm B, we are going to have a standard deviation of 11 given as such. So I'm going to reserve these specific values of the standard deviation for the two firms or the two industries given as such, and that's going to assist us in trying to evaluate the various coefficients of variation for firm A and B are given as such. So the mean wages, of course, have been given in terms of the mean wage for A is equivalent to 52.5, and the mean wage for B is given as 47.5 in that particular order. So those specific values are going to assist us in evaluating the coefficient of variation. So we shall have the coefficient of variation for firm or the industry A given in terms of the standard deviation of A divided by the mean of that specific firm times 100, which is equivalent to, of course, 10 divided by the value of this one is 52.5 times 100, and this is going to give us the value of 19.05. So I hope it's legible, so let me put it here. So this is going to be 19.05% as the coefficient of variation of the industry A given as such, and we shall compute the coefficient of variation for industry B as the standard deviation of B divided by the mean of the mean wage of B times 100, and this is going to be 11 over 47.5 times, of course, this 100, and this is going to give us the value of 23.16% given as such. So this is going to assist us compute variability of those specific wages for the two different industries, and this is going to be, of course, essential for us in finding which farmers got greater variability in terms of their wages given above. So therefore, as we can see, there is a relationship between the two. For the coefficient of variation for industry or for industry A is smaller than the coefficient of variation for industry B given as such. Therefore, we can describe this specific industry which has got a higher coefficient of variation as having greater variability of these specific wages. And that's how we're going to use the coefficient of variations in trying to consider different sets of data insofar as their variability is concerned. I hope that we have understood the concept of the coefficient of variation, which basically in summary form I've mentioned as the ratio between the standard deviation and the mean expressed as a percentage. And given some set of data like this one, of course, we're going to use the same procedure in trying to find this specific aspect of the coefficient of variation using this particular procedure which I've done. So I hope that that's okay. So I kind of like to request our members to check our description box for various links of other similar videos, and also subscribe and engage us in the comment section for more. So that's it for now, guys. Bye, God bless you. Catch us in our next video.